Hello, everybody. This is basically the answers to practice questions. I hope everything is crystal clear for you, but just want to go over them quickly to make sure we have a clear understanding of what the question is asking. In the worksheet, everything is clear. The only thing you have to pay attention when you have a work question is that you always look for the applied force. When we did Newton's second law, it was about net force. So net force was equal to mass times acceleration. So if there was friction, you had to be careful. But when we do work problems, we only look for a specific applied force. And the applied force here is 0.47 Newton. So that's what I use and I calculate my force. But sometimes they trick you and they say, well, what if I have the force of friction, like in question number 2? You simply have to ignore it because yes, there is a work done by friction, but they're asking you calculate the work done by this force, by the force which is 0.47. So you want to make sure you pay attention which force they're asking you to find the work done for. If they ask you what is the work done by the force of friction, then you have to use this F instead of that one. But in work calculations, we barely use the net force. Okay, I hope that's clear. That's the only tricky thing in work problems, that we always have to focus on the applied force. So the formula is the applied force, and the question is asking the work done by this force. If they ask you what is the work done by force of friction, then you can use that. Again, question number 3, another tricky thing is they give you weight or mass. When I'm moving horizontally, mass is irrelevant. The force of gravity is always canceled with the the force of gravity is always canceled by the force we call normal force. So if the object is moving horizontally, they're just simply irrelevant because I'm not doing any work. Why? Because my force and the force of gravity will have 90 degrees angle, and a cosine of 90 is 0. So basically, I am not going to consider mass in my calculation if I'm moving the object across the table horizontally. Only when you're lifting something up, then you have to calculate, because then the direction of your applied force is not perpendicular to the direction of movement. They're in the same direction. Okay, so the work done by you over there, you have to consider the mass in there by calculating the force of gravity. But in this situation, this 400 grams is completely useless. Similar to the next question, again, they give you the force and they give you the work, and you have to calculate the distance traveled. So how far is moving? You rearrange the formula and you calculate. But again, they give you mass, which is completely useless because again, you are moving horizontally, not vertically. Question number 5 is what I was telling you. When you're moving an object vertically, that's the time that your applied force has to be equal to force of gravity or bigger. If something is so heavy and you can't move it, then you're not doing any work. That means you're not transferring your energy into the force of gravity. So it's very important that you know when you're moving something vertically, your applied force has to be equal to force of gravity. And that's why they don't give you the information. They don't tell you the applied force, but they simply give you the mass in here. And once you have the mass, you can calculate the force of gravity and use that as your applied force to calculate work. Next question, again, very simple. You just have to rearrange it to find the applied force, which will be equal to work divided by distance traveled. Number 7, again, they're tricking you. They give you a force of, applied 300 Newton, and they say, what if the force of friction was 200? What if it was 300? Whatever the force of friction is, I don't care, because the question says, how much work does she do? And the only thing I can use for her is the force she's applying, nothing else. Friction is not going to be used. Friction, the only thing friction does when I'm doing work, it's removing energy from the entire system. So it's changing the energy, but it doesn't do anything to my work. I eat food, I apply force, it's the work I do. So you have to always be careful when you do work problems. The friction is now going to play a role in both cases. In question number 7, it's always what you do. Doesn't matter what the friction is. What you do is 300 Newton times 750 meters. That's how much energy you transfer into the system. Yes, friction is going to remove some of the energy from the system, but it's irrelevant. How much work you do. And then the next question is basically similar. It's good. If I'm not moving the object, doesn't matter how much I push it, doesn't matter what is my force. If it's not moving, I have done no work at all. And now the next question, little tricky because you have to calculate D, and that's from the first unit. D is equal to V times distance. Time, V times time. And I think the final answer over there is wrong, unless I did something wrong, but the final answer you had in your answer sheet did not match. So I'm thinking something went wrong, but the key is here's 30 minutes. This is 0.8 meters per second. You have to change that to seconds. And when you multiply, the D is 0.4. And now your work done will be 40 Newton times this distance, and you can calculate 16 Newton. So these are all the work questions. I will post this also online so you have it separately from this video. But we get to kinetic energy. Again, the worst they can make the kinetic energy problems is that to give you the mass in terms of grams. So a lot of places, you, instead of having kilograms, you get the mass in grams. So all you have to know is change it to kilograms. Or they give you speed in kilometers per hour. You have to change it to meters per second, because the formula for kinetic energy, E is in joules, therefore your mass has to be in kilograms and your speed has to be in meters per second. Any other unit you get, you have to convert it. That's the only thing. And the rest of them, you just have your formula sheet, everything is rearranged, and you substitute and calculate. And I can show, I've showed you here that again, the mass in question number 3 is in grams, the speed is in kilometers per hour, so I converted both to calculate the kinetic energy. For here, number 4, in kilometers per hour, make sure it's in meters per second before you can substitute it into your equation. You have the rearranged form in your formula sheet for speed. And question number 5 is a continuation. Question number 4, it just says, if my energy is half of before, what's going to happen to my speed? So that's why you have to divide this energy by 2 before you substitute it here, which I did here. And when you do that, the 2 and the 2 cancels, and the answer becomes 15.7 meters. So it's a square root of everything. Be careful that the whole 2ek divided by mass is under the radical, right? You have to calculate the square root of the entire thing. Don't leave m outside. This whole thing goes under the square root. And I think your final answer in your answer sheet, the answer is in kilometers per hour. So my answer will, because of my formula, comes 15.7 meters per second, which you have to convert it again to kilometers per hour. And so if you have any questions, please email me and let me know, and I can explain more. And the last question you had pretty much was related to different energies, which you use the speed formula. Very simple, very straightforward. Again, in kinetic energy problems, what they do, they make you change meters per, I mean, kilometers per hour to meters per second, or they give you mass. In work problems, again, they play with friction because they want to confuse you with the net force. All the work problems are dealing with the applied force. And if my object is moving horizontally, I do not care about the mass. If I'm lifting something, then my applied force becomes the force of gravity, which is mass times g. Okay, thank you for listening.